With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, our question is given as space is divided by the line AD into two regions. So here two regions are there, region 1 and region 2. Region 1 is field free and region 2 has a uniform magnetic field B. Direction into the plane of the paper. So it is given in the figure, that is region 1 is free field, there is no magnetic field in region 1, and in region 2 there is magnetic field which is applied perpendicular to that paper. Okay, ACD is a semicircular conducting loop of radius R with a center at O. Okay, so we can see in the figure ACD is a semicircular conducting loop at the center O. Okay, the plane of the loop being in the plane of the paper. The loop is now made to rotate with a constant angular velocity omega about an axis passing through O, and that axis is perpendicular to the plane of the paper. So the effective resistance of the loop is R is given. Our question is to find, there is two parts. First part is obtain an expression for the magnitude of induced current in the loop. Second one is show the direction of the current when the loop is entering into region 1 and plot a graph between induced e.m.f and the time of rotation for 2 periods of rotation. Okay, so we can analyze what is given and we can find the expression for the magnitude of induced current. Let me draw this diagram in another region. That is, see this be that line. Okay, that means separation line which is given as AD, and here there is a magnetic field which is given into the plane that is perpendicular to that portion. Okay, and here first of all the semicircular ring is placed as in the figure. When it starts rotating, let this be the position when it rotates. So this be the semicircular ring when it rotates. Okay, so this be the radius center O. Okay, so this is the length radius, this is also radius. So we need to find the position arc. Okay, and let this angle be theta. At an instant this angle be theta. So what is this arc? Arc is equal to r theta. Okay, so we can construct a triangle from this figure. From this figure we can construct a triangle, and what is area given? Area is equal to half into base into height, that is r square theta. This is the area given. Okay, first we are asked to find induced current. For that, first of all we need to find induced EMF. Okay, so induced EMF is given by EMF is equal to minus d phi by dt. Okay, what is phi here? Phi is a magnetic flux, that is magnetic field into area. Therefore, EMF is equal to minus d by dt of magnetic flux into area. Okay, what is area given here? 1 by 2 r square theta, substituting d by dt of b into 1 by 2 r square theta. Here magnetic field is constant and the radius of the loop is also a constant. So minus b r square by 2 into d theta by dt. What is d theta by dt? It is angular velocity. It is angular velocity given by omega. So we get the equation of EMF as EMF is equal to minus BR square omega divided by 2. What is the induced current? Therefore, induced current is obtained by induced current I is equal to EMF divided by effective resistance, that is minus BR square omega divided by 2R. So this is the first part asked. That is what is expression for the magnitude. So magnitude is given by modulus of I is equal to BR square omega divided by 2 into capital R. This is our first question. What is the second question asked? To find the direction of the loop when it is enter into the region 2. So this is region 1 and so this is region 1. This is region 1 and this is region 2. So region 2. So it is asked when the loop enters into the region 2. Okay, since the direction rotation is given like this, and using the right hand thumb rule. Right hand thumb rule here, the folded finger will be taken in the direction of the magnetic field, which is into the paper, and the thumb gives the direction of the current. Okay, so here the thumb gives the direction in the anti-clockwise direction. So the direction of the current when it is enter into the region is given as anti-clockwise direction according to right hand thumb rule. Okay, so what is the next one we asked? It is asked to find the plot of the graph between induced EMF and the time of rotation for 2 periods of rotation. Okay, so let capital T. So when the semicircular loop completes one rotation, let T be the time period for the total rotation. Okay, so we can find that let capital T be total time period for complete rotation. Okay, for complete rotation. So for the half rotation, that is first the loop is in the region 1. For the region 2, what will be the time for half the rotation? The time is equal to T divided by 2. Until that half rotation, the current will remain constant. So we can draw the graph by taking y-axis and x-axis as, okay, here I am going to plot the graph here. Here there is induced current and here the total time period, and let this point be a constant value b r square omega divided by 2r. So up to time period t by 2 and the next time period is t. Let me extend this graph. Okay. So here t next is 3t by 2. Okay. Okay. Next is 2t. Okay, so up to 3t by 2, it is in a clockwise, anti-clockwise direction up to t by 2. Then what happens? So first let this be AD. So this be the circular, semicircular loop. When it starts its rotation, what happens is that I will draw that thing also. It will pass us into the region. Okay. Region 2. Then it will complete the rotation in region 2. Then it start in the opposite direction. Okay. So here be theta. So what happens is that here the current direction of the current is clockwise direction. Okay, so the graph will be maximum value in the negative region up to t. Next, it will repeat up to 3t by 2. Okay, so this is a graph between the induced EMF and the time for the 2 rotation. In the first rotation, when it is until it reaches the region 2, the induced current will remain constant. When it reaches the region 2, it starts to rotate back to region 1. Then the direction changes, but the value of the current doesn't changes. Then the process repeats. Okay, so here this is a method how we find the current induced in the semicircular loop. Okay.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.